Know the unit circle. In this video lesson we'll discuss how to find the 16 points of the unit circle. Then we'll go over techniques to help us remember these 16 points in the unit circle. Most video lessons I see on this topic tend to emphasize memorizing the unit circle. I have deliberately entitled this video lesson Know the Unit Circle because I think memorizing the unit circle will be easier and better if we understand or know where these numbers come from. That's why I call this lesson Know the Unit Circle. From the video lesson that precedes this one, Create the Unit Circle, we took the unit circle equation x squared plus y squared equals 1 and graphed this circle. These are the 4 points on that unit circle that represent angles of 90 degrees, 180 degrees, 270 degrees, and 360 degrees. For points on the unit circle represented by coordinate pairs, the cosine is x and the sine is y. These angles can be measured in degrees. We have 90, 180, 270, and 360 degrees. Or radians, and we have pi over 2, pi, 3 pi over 2, and 2 pi radians for these same angles. Now we'll work on finding and describing the 12 other points of the 16-point unit circle. 3 of the points will be located in each of the 4 quadrants. But to really analyze the points, it will help us to zoom in on the first quadrant, here within the green rectangle. And here is the first quadrant of the unit circle. And here are the points and angles already established. Here's a protractor we'll use to help us locate the angles we need. And here are the 30 degree, 45 degree, and 60 degree right triangles we'll use to locate these points, the other 3 points in quadrant 1. The 30 degree right triangle is green, the 45 degree right triangle red, and the 60 degree right triangle purple. All angles in the unit circle are multiples of 30 and or 45 degrees. We'll work on the 30 degree triangle first. Going back to 9th or 10th grade geometry, we learned that the sides of this triangle can be described as x for the short side or vertical leg, x square root of 3 for the horizontal leg, and 2x for the hypotenuse. And since the hypotenuse of the triangle is the radius of the circle and the radius of the unit circle is 1 unit in length, we can set 2x equal to 1. So 1/2 is the length of the vertical leg of this right triangle. And for the horizontal leg, since x equals 1/2, x square root of 3 equals 1/2 times x, which simplifies to the square root of 3 over 2. And accordingly we can so label the horizontal leg of the triangle as square root of 3 over 2. So now we can give the coordinates of this point, which are square root of 3 over 2, comma 1/2. And convert to radians, we label the angle as pi over 6. Now we go to our next triangle, the red triangle with the 45 degree angles. Again, going back to 9th or 10th grade geometry, the sides of this special right triangle are x and x for the legs and x squared root of 2 for the hypotenuse. And since the radius of the unit circle is 1 unit in length, we can set x square root of 2 equal to 1. And solving for x equals 1 over the square root of 2. And to rationalize the denominator, we can multiply by the square root of 2 over the square root of 2, which simplifies to the square root of 2 over 2, which we can now use to label the horizontal and vertical legs of the triangle. So this point is identified by the coordinate pair square root of 2 over 2, comma square root of 2 over 2 at 45 degrees. And the angles representing this point are 45 degrees and converted to radians, pi over 4 radians. And now our triangle with theta equals 60 degrees. These sides in this triangle are the same as for our 30 degree triangle, except x is at the bottom leg and x squared root of 3 is on the vertical leg of this triangle. Since the radius of the unit circle is 1, we can again set 2x equal to 1, and solving for x equals 1/2. So substituting 1/2 for x, we get the vertical leg equals 1/2, and the vertical leg equals the square root of 3 over 2, which means our coordinates for this point are 1/2, comma square root of 3 over 2. And we mark the angle measure of 60 degrees and the radian angle measure of pi over 3. Here the quadrant 2 portion of the unit circle is added to this image on the left side of this view, and here are the points from quadrant 2 added along with their angle positions in degrees and in radians. These points in quadrant 2 are reflections about the y-axis of these points in quadrant 1. Therefore, all the x-coordinates are negative in quadrant 2 while the y-coordinates remain positive as they were in quadrant 1. Here are quadrants 1 and 2 of the unit circle with all the arrows cleared out of the way. Now here's the complete unit circle. I want to emphasize two things. First, the y-coordinates in both quadrants 3 and 4 are negative, just reflected about the x-axis from above. And secondly, the cosine is x and the sine is y. For all these coordinate pairs, the x-coordinates are all cosines of the angles and the corresponding y-coordinates are all sines of these angles. If you are taking calculus, you need to know this unit circle cold, especially the first quadrant. Why especially the first quadrant? Mainly because if you know the first quadrant cold, you'll be able to, using reflections, figure out the rest of the unit circle quite easily. Now for the memorizing part of this lesson. Some people just try to memorize the circle by brute force, just by sheer repetition, implanting the material in the long-term memory of the left brain with time and persistence. There are dozens of tricks for memorizing the unit circle, but I'll share the method I use with my students. I have a unit circle t-shirt that has this exact graphic of the unit circle in the front of the t-shirt, and has this graphic on the back of the t-shirt with these 5 numbers, 0, 4, 13, 22, 31, and 40 going from upper left to lower right. Step 1. Separate each pair of digits with a comma. Step 2. Divide each of these separated by comma digits by 2. Step 3. Take the square root of each of the numerators. Step 4. Simplify. The coordinate pair at the bottom right simplifies to 1, 0 and is for the angle of 0 degrees or 0 radians. This angle is also for 360 degrees or 2 pi radians with complete revolution. The next coordinate pair up simplifies to square root 3 over 2, 1/2 and is for the angle of 30 degrees or pi over 6 radians. The next point does not simplify further and remains square root of 2 over 2, square root of 2 over 2. The angle represented here is 45 degrees or pi over 4 radians. The next point up is for 60 degrees or pi over 3 radians, and the cosine and sine are 1/2, the square root of 3 over 2. And the last point at the upper left is 90 degrees or pi over 2 radians, and the cosine and sine simplify to 0, 1. It's a bit of a trick, but should be one pretty easy to remember and to apply. There's one more facet of memorizing I would like you to take a look at. It's an aid to remember the signs of the trigonometric ratios for each of the 4 quadrants. It is the 4-word sentence, all students take calculus. And each word in this sentence goes in order in quadrants 1 through 4. All is in quadrant 1, students in quadrant 2, take in quadrant 3, and calculus in quadrant 4. This memory aid means that all trigonometry ratios or trigonometric ratios in quadrant 1 are positive, sine, cosine, and tangent. In quadrant 2, students means that the ratio beginning with s or sine is positive, meaning that cosine and tangent will be negative. And in the third quadrant, take means that the tangent is positive while the cosine and sine are negative. In the fourth quadrant, calculus means that the ratio starting with c, cosine, is positive while the sine and tangent are negative. One last thing for memorizing. I have a friend, Mark, who has written a bunch of songs about calculus and pre-calculus and has a song about unit circle trigonometry. If you click at the right on the image I have from a video someone made using that great song, you'll be taken to that video. To me, the most important part of the song is the cosine is x and the sine is y. Anyway, this song might be enjoyable after watching this video lesson up to this point that shows how these points are derived. This has been Know the Unit Circle. Thanks for viewing.